Okay, so hopefully you had a little read of example 2 on the top of page 18. It says the beach at British Bay slopes downwards at a constant angle of 12 degrees to the horizontal. How far out into the sea can a man walk before the water covers his head, and make assumptions as necessary? Okay, so again, no diagram there, so what we do, let's sketch something. Let's make it a little bit easier. So, in example 2, right, so this is what we have. There's a guy who's going to walk out to sea. And obviously what he's going to do is he's going to see how far he can go out before the water actually covers his head. So we got to use your common sense here. Got to use, just think logical about this. What will determine how far anybody walks out? Obviously it's going to be their height. Right? So if you have a little brother who's smaller, he's not going to be able to walk out as far as you can. If you have an older brother or sister who's taller, they're going to be able to walk out a little bit further. So if we think about the actual dimensions of this, right? This here, that there is the top of the sea. That's what you see. And you would start here, and you'd start walking. And as you start walking, you'll start walking into the sea like this. Right? So that's what's going to happen. So we've got an angle like that, which is an angle of 12 degrees. Right? So it's that angle of depression there of 12 degrees. And then what will happen, eventually, we've got a guy here, let's just say it's me. Right, so there's Carl there, and his head now is underneath the water. And what we now need to find is we need to find that distance there. We need to find that horizontal distance. Now we're going to assume that Carl's head and the sea are perpendicular with each other, right? Because we have to have that right angle triangle. So remember, what will determine how far anybody goes out? It's how far Carl how far Carl walks out will determine, will be determined by his height. So we'll now pick a height, right? So we'll pick a height. You can pick a height for me. I'm going to say 2 meters, right? I'll be very optimistic there. I'll say I'm 2 meters. But please, when you get a question like this, a lot of students, I'd often have students in a class and I'd say, what height are you? And they naturally will say, what? I'm 5'6", I'm 5'7", I'm 6 foot. But we've got to write in meters, okay? Really important that we write in meters. And then we just go and use a strategy. Right angle triangle must be trig. If it's trig, it's either Pythagoras or sin cos tan. In this case, we can't use Pythagoras because we don't have enough information, but we can use sin cos tan. What's the first thing that we always do with sin cos tan? We label our sides. So this here, obviously, is going to be the hypotenuse. That's the angle that we're dealing with, so this side here is going to be the opposite. And then that distance there, that x that we're looking for, is the adjacent. So based on that, what trig function will we use? Remember, we've got the opposite, and we want to find the adjacent. So what trig function will it be? Well, it has to be tan. So tan of the angle, tan 12, is equal to 2 over x, and then go and isolate your x. And that's how we approach that question. Okay? So, as I said, even though it's angles of elevation and angles of depression, it's actually just going back to using sin, cos, and tan, these trig functions. And that's pretty much the same on page 20, when we're looking at these from one to another. So if you go to page 20, and if I just do one question on it, it does seem to be different, right? So it does seem different, but it's actually just using sin, cos, tan and Pythagoras. Now, I've given you the steps in the notes, right? So the steps are there in the notes. I'm just going to go straight into a question. It says, example 1, if sin x is equal to root 7 over 4, find the value of cos x. Right, so example 1, we're told that sin x equals root 7 over 4, and we're asked to find the value of cos x. Right, so let's think about this logically. Sin x, it's our trigonometric functions. What is the trigonometric function of sine? So we're going to use our SO, cat, toa, and sine is equal to the opposite over the hypotenuse. Right, so remember, I'll just write it here just in case. So, cat, toa. Sine, opposite over hypotenuse. So root 7 is the opposite for the hypotenuse. What are we asked to find? We're asked to find cos x. And what's the trigonometric function of cos? It's adjacent over hypotenuse. Okay, so that's the adjacent over hypotenuse. Now look, we know what the hypotenuse is. The hypotenuse is 4. But we don't know what the adjacent is, right? So what I recommend you do is just sketch a little right angle triangle. Right, so there's a right angle triangle. We can say that we know what sin x is. It's opposite over hypotenuse. So we can say that this is 4, right? And if we say that this is x, That there is the opposite of it, so that has to be root 7. And then this here must be the adjacent. And remember, it's right angle triangle, right? So it's trigonometry. Now if it's trigonometry and we want to find the adjacent, that's what we want to find. We want to find that side there. How do we find that side? Look at the information that we have. It's right angle triangle. We've got two sides. How do we find the third side in a right angle triangle when we already have two sides? It must be what? It has to be Pythagoras. What do we do when we're using Pythagoras? We did it a few minutes ago. We write the formula. C squared is equal to A squared plus B squared. Now what's C? It's always the longest side. In this case, it's the 4. So 4 squared equals root 7 squared plus the adjacent squared. 4 squared is 16. What happens when we square a square root? That's going to cancel. That's equal to the adjacent squared. Now let's just isolate the adjacent. Let's subtract, plus the adjacent squared. Let's isolate the adjacent, right? So let's get rid of this 7, subtract 7 on both sides. If we subtract 7 on both sides, we get 9 is equal to the adjacent squared. And how do you get rid of the squared? We're going to have to get the square root. So if we get the square root of both sides, 3 is equal to the adjacent. And then we take that value of the adjacent, which is 3, and we bring it back up here to the adjacent. So cos x, which is equal to the adjacent of the hypotenuse, must be equal to 3 over 4. Right? And that's it. And that quite very similar was asked in 2018. In 2018, we were told what cos f was. We were told that cos f was equal to 6 over 11. And the examiner said, by drawing a diagram of a right angle triangle, find the value of sin f in short form. So he told us what cos f was. Then he said, go and draw a right angle triangle and find the value of sin f in short form. So if we were to do that, right, so there's our right angle triangle. We would have our f here. Right, there's our f. That would have to be 11. That there would be the opposite. This would be the adjacent, which is 6. And we're asked to find sin f. And what's sin f? It's the opposite over the hypotenuse. So we need to find this here, the opposite. But we know that this is a right angle triangle. And if we have two sides of a right angle triangle, how do we find the third side? Well, we just have to go and use Pythagoras. So c squared equals a squared plus b squared. So the longest side is c, so 11 squared is equal to 6 squared plus the opposite squared. So 121 is equal to 36 plus the opposite squared. We'll now subtract 36 from both sides and we'll get 85 is equal to the opposite squared. And if 85 is equal to the opposite squared, what's the opposite? It has to be the square root of 85. So the square root of 5 is equal to the opposite. And then what would sin f be? So sin f, opposite of a hypotenuse. What's the opposite? Square root of 85. And what's the hypotenuse? It's 11. It's a really, really straightforward question. We're really just bringing it's an amalgamation of using Pythagoras and our trig functions, which is very, very, very straightforward. And there's a couple more of those on page 21. You can try yourself. Very straightforward. If you can do that one, you'll have no problem. Another one on 22. And then the final area that we have to do on page 23 is evaluating trig functions. And ultimately, all we're doing is using our calculator there. So all you're doing is using your sin button on your calculator, or your tan button on your calculator, or your cos button on your calculator. I've said to you previously that the question will revolve around either Pythagoras or sin cos tan. If the question is trigonometry and it's not Pythagoras or sin cos tan, it'll be just using a calculator. And everyone can use a calculator. Very, very, very straightforward. Okay, so all you're going to do is use your calculator. Now, we're after spending the last hour kind of going through those main areas that are on the syllabus based on trigonometry. Now, really, to bring this all together now, in terms of what we do in our classes, it's ultimately about you doing exam questions. So what I'm going to now do is, before we finish up this back to school course, I'm going to go through some of the exam questions that you'd expect to come up in June 2021. Okay? So, if you have a look, from page 24, we've got past and probable exam questions, right? And these are the type of questions that would come up, okay? That you would expect to come up next June. Now, on page 24, this came up in the 2018 exam. And it says, the diagram below shows our Horcrux. It's something in Harry Potter, I know that. So if anybody's into Harry Potter, I think it's some symbol in Harry Potter, the Horcrux. I've never seen any of them. But no doubt someone will know something about the Horcrux. It says ABC is an equilateral triangle. What's an equilateral triangle? 3 sides are equal. 3 angles are also equal. D is the midpoint of BC, and AD is perpendicular to BC. So if AD is perpendicular to BC, what do they form when they're perpendicular? Right angles. So the minute you see that perpendicular, you're like, right angles, right angles. What must it be? Right angle triangle. What must it be? Trigonometry. If it's trigonometry, it's either what? Pythagoras or sin cos tan. So instantly, like, the alarm bells are going off. It's like that eureka moment in the exam. Yeah, deadly. I know what this is. It's trigonometry. It's either Pythagoras or sin cos tan. It says the circle K touches three sides of ABC. And A says a little bit, now we haven't done this first part A, it's a little bit of geometry. It's a synthetic geometry that you will do within the class. It says write the correct transformation into the box below and be as specific as you can. ABD is the image of ACD. It's actually under axial symmetry in the line AD. Now I will actually I'll try to draw it. Okay, so this is the diagram that we have. So we've got our equilateral triangle like that, and there's like a circle going around that, and then this line drops straight down. And when it drops straight down, well, this is perpendicular, so that's a right angle and that's a right angle. So that's what's going on. And the question says ABD for so that's A, that's B, and this is D, and that's C, and it says ABD, so ABD is the image of ACD, and it's under axial symmetry in the line AD. So that triangle, so ABD, is going through that line, and it will form ADC. Right? So under axial symmetry in the line AD. Now, part B. This is what I'm interested in, because this is what we did in this back to school course. Okay? So it says AD is equal to 10. Work out the length AB, give your answer in centimeters in surd form. So we're given, in the main actual diagram, we're given an equilateral triangle. And what we're asked to find is AB. Now, where is AB? AB is here, right? So what we're really going to do is we're going to take this equilateral triangle, but we're going to take the triangle ADB out of it. Right, so we've got A, D, B. And the examiner wants us to find A to B. I'm going to call that X. Now, what other information do we know? He told us, so if we just look here, just to be clear, he told us that AD is perpendicular to BC. Ah, there's our right angle triangle. That's our trigonometry. That's our Pythagoras or sin cos tan. And if we go back to the actual original information that he gave us, he says that ABC is an equilateral triangle. So the three angles, that angle there, 60 degrees, that angle there, 60 degrees, that angle there, 60 degrees. So we're going to use that angle there, that must be 60 degrees. Alright, so, you're like, right, grand, right angle triangle, trigonometry, Pythagoras or sin cos tan. Do we have enough information to use Pythagoras? We don't, but could we use sin cos tan? Our trig functions? We could. What's the first thing we do with our sin cos tan? We label our sides. What must x be? It's the hypotenuse. If that's the angle that we're looking for, right? That's the angle that we're looking for. This here is clearly the opposite. And remember, he tells us that A to D is 10. Right? So that A to D is 10. That side there is 10. So what we're looking with, or what we're working with here is, we're working with the opposite, which is 10, and we want to find the hypotenuse. So if we think about our SOHCAHTOA, SOHCAHTOA. Right? What's the story of SOHCAHTOA? Which one are we going to use? Remember, we have the opposite, and we want to find the hypotenuse. So it's O and H. Where is O and H? Is it sin, cos and tan? It's not that. It's not that. It has to be sin. So sine of the angle, sin 60, equals what? The opposite, which is 10, divided by the hypotenuse, which is x. And then what we've got to do is we've got to go and isolate that x, right? So x equals 10 divided by sin 60. And we can go and put that into a calculator. But the strategy definitely works. That's what we're going to use. We've got to use that strategy to apply it to any of those questions. Right. We don't have a huge amount of time left, okay? But again, the strategy is so important. Have a look at question 2 and apply the strategy to question 2. Question 3 is fine. It's just using the calculator. If we have a look at, say, question 4 on page 27. Let's have a look at question 4 on page 27. Now, for me, question 4 was asked 2012. Right? It's gone back a good while. But it's probably one of the most challenging trigonometry questions on it. Right? But if you use your strategy, it should be absolutely fine. And let's use that strategy now. So question 4 says, two vertical poles A and B. So it's page 27, question 4. Two vertical poles A and B, each of height h, are standing on opposite sides of a level road. They're 24 metres apart. The point P on the road directly between the two poles is a distance x from pole A. The angle of elevation from P to the top of pole A is 60 degrees. Write h in terms of x. Let me draw for you, right? Let me draw to make sure you know what's going on. So this is question 4, and this is what we have. Okay, so we're told that this is pole B, we're told that this is pole A. We're told that this is 60 degrees. This is P, this distance here is x, this is h, and the entire distance from the poles is 24. Okay? And this is 30 degrees, and then this is h. Okay, now, what the examiner will often do is he'll often give you like a couple of right angle triangles to work with, or a couple of triangles. And just bear in mind, if I just read the question, it says the first 3 words are the two vertical poles. So they're vertical poles. That's the pole there. Now think of lights, poles. How are they kind of erected? How are they placed? They're always the poles aren't placed like that. Sure they aren't. They're placed like that. So they're creating what with the ground? Right angles. So the instantly we should be like, that has to be a right angle. And that has to be a right angle. Because if they're right angle triangles, what the question must it be? It must be trigonometry. And if it's trigonometry, it's either going to be Pythagoras or sin cos tan. Right? So that's the approach to the question. Now, if you look at this question, it gives us two right angle triangles. And what I would always do is, I would always label them. Because you'll only have to deal with one of them at once. Right? So you'll only have to deal with one at a time. So I would label this one here, like that right angle triangle 1, and I'd label this one here, this right angle triangle 2. So we got 1 and 2. Now the question says, write h in terms of x. Where is the h and the x? Well, we've got a h there, right? In that right angle triangle 1. But we also have a h here in right angle triangle 2, and we also have an x in right angle triangle 2. So what right angle triangle do you think we'll deal with? Well, where is the h and x? It's in this one, right? It's that one there. So if I was just to take that right angle triangle out, I'm just going to take it out, work on its own, 60, x, h, that's what we have. And the examiner says, write h in terms of x. What does that mean, write h in terms of x? It means h equals something x. Right? Now, remember, it's a right angle triangle. Has to be trig. It's Pythagoras or sin cos tan. Will Pythagoras help us here? It won't. Will sin cos tan? It will. What's the first thing that we always do with sin cos tan? We label our sides. Hypotenuse. Opposite. Adjacent. Now what two sides are we dealing with? We're dealing with the h and the x. H is opposite, x is adjacent. What trig function is opposite and adjacent? So, cat toa, it's tan. So the tan of the angle, what's the angle? The angle is clearly 60. Tan 60 is equal to the opposite, which is h, divided by the adjacent, which is x. Now what did the examiner say? Write h in terms of x. H equals something x. What's that x down there? Dividing. We send it over the other side, what are we doing? Multiplying. H equals tan 60 multiplied by x. And then a lot of students will go and get tan 60, which is root 3, h equals root 3 by x. So even though this question seems so much different, the strategy that we apply to it is identical. trig, Pythagoras, sin, cos, tan, done. Right? That's the way we're going to do it. Alright? So that's the first part of the question. The second part, B, it says, find P, the angle of elevation to the top of the pole. Sorry, it says, from P, the angle of elevation to the top of pole B is 30 degrees. Find H, the height of the two poles. Right? So I'll read that again, and I'll do it from this diagram. Right? So it says, from P, the angle of elevation to the top of pole B is 30 degrees. Find H. So from P, the angle of elevation to the top of pole B is 30 degrees. Find H. That's what the examiner is asking us to do. Do we actually know what H is? Look, come back here. What is H? H is equal root 3 by x. So really, for us to find H, we need to find out what x is. Because we'll multiply root 3 by x. Now if you look again at the question, it says, from P, the angle of elevation to the top of pole B is 30 degrees. So the right angle triangle that we want to use is right angle triangle 1. So if I just draw a right angle triangle 1, right, we know that this is 30. Now we know that this here is H, but we also know that H is what? Root 3 by x. Right, so that's root 3x. And can we find anything else here? Well, come back to the original diagram. That distance there is 24, and that distance is x. So how would we find that distance there? Well, we clearly subtract x from 24. 24 minus x is equal to that. So I'm going to call that 24 minus x. Now, remember, it's a vertical pole. So that's a right angle. If it's a right angle triangle, what type of question is it? It's trigonometry. If it's trigonometry, it's either Pythagoras or sin, cos, tan. Could we use Pythagoras here? No. Could we use sin, cos, tan? Yes. What do we always do when we're using sin, cos, tan? What's the first thing that we always do? We always label our sides. So we label our sides. This here has to be the hypotenuse. This here has to be the opposite. And this here has to be the adjacent. Now, what two sides are we dealing with? We doing anything with the hypotenuse? We're not. We're dealing with the opposite and the adjacent. So, cat, toa. What trig function is it? It's tan. So the tan of the angle, in this case, what's the angle that we're dealing with? It's 30 degrees. So tan 30 is equal to the opposite, which is root 3 by x divided by 24 minus x. And now we have to go and find the value of x. Tan 30 is 1 over root 3, which is equal to root 3 by x divided by 24 minus x. Now just be careful here. A lot of students might struggle. All we want to do is cross multiply. Right, so we're going to cross multiply. And if we cross multiply, what we're going to get is 1 multiplied by 24 minus x equals root 3 by root 3 by x. 1 multiplied by 24 minus x is 24 minus x. Root 3 by root 3? Oh, unbelievable. That's 3. It's like root 3 squared. And the square and square root will cancel each other. So that's 3 by x. Oh, this is working out so nice. Bring over the minus x. So it'll become plus x. 24 equals 3x plus x, which is 4x. So if 24 is equal to 4x, x is equal to 6. Unbelievable. Works out so nicely. But we weren't looking for x. What did the question say? Find h. What was h? There it is there. H is equal to root 3 by x. So h equals root 3 by 6. And that is approximately 10.39 meters. But even though that question seems really difficult, what are we going back to? We're going back to our core strategy. That core strategy of recognizing that it's a right angle triangle, two vertical poles. If it's a right angle triangle, it must be trigonometry. If it's trigonometry, it's either Pythagoras or sin, cos, tan. The more difficult questions, you're most likely going to use sin, cos, tan. But apply that to all those questions. Apply it to question 5. Like question 5, very straightforward. Apply it to question 6. Apply it to question 7. There is loads and loads and loads there. Like, if we have a look at one more before we finish up, go to page 33 and let's have a look at question 10. Right, so we'll do one more. Let's bring it all together. And ultimately, this is what we do in the weekly classes. It's like, how can we prepare ourselves for this exam. How can we maximize our potential in this exam? So in question 10a it says, the diagram below shows two right angle triangles, ABC and ACD. They have right angles. Unbelievable. Right angles. Right angles, trigonometry. They have right angles at B and D respectively. We're given information, let me just draw it. Right, so question 10. And by the way, this was asked in 2018. And this is what we're given. So right angle, how's he drawn it? I was drawing it the other way. So it's terrible. So right angle, call it this is X, call it this is X. That goes on over to there. This is C, this is A, that goes out like that. And then this here is also a right angle. Right, so that's also a right angle. And we're told that this is 10 and this is 12. Alright? And that's all the information we have. A, B, C, D. Lovely. And the question says, part 1. Using trigonometry, use trigonometry to find the size of the angle y. Give your answer correctly in decimal place. Now, what you will notice in here as well is that a bit like the previous questions, many right angle triangles that we have, we have 2. So let's call one of them 1 and the other 2. Now we're asked to find y. Right? So what right angle triangle are we using? We're using right angle triangle 1. Like y is in 1. So if you took it out on its own, you don't even have to, but this is what you have. That's 10, that's 12, that's y, and that's our right angle. Right angle must be trig. If it's trig, it's either Pythagoras or sin cos tan. Can we use Pythagoras to find size of angles? We can't, but we can use sin cos tan. First thing we always do, we label our sides. That's our hypotenuse. This is our opposite. And this is our adjacent. What trig function will we use? So we were given our adjacent and our hypotenuse. So think of our saw, ka, toa. So A and H has to be cos. Cos of the angle, cos of y is equal to what? The adjacent 10 of our hypotenuse 12. If we're looking for an angle, what have we got to get? We've got to get a shift. Done. Right? And obviously read the question. The example says correct to 1 decimal place. That works out as 33.6 degrees. Always read the question. The units are really important. Okay, so make sure you put them in. And in the second part it says find the value of x, correct, give your answer correct to 2 decimal places. Where is x? What triangle is x in? It's in triangle 2. So again I take that out. Again it's just a quick sketch. That's x, that's a right angle, and that's 12. Right angle triangle, what type of question is it? It's Pythagoras, it's trigonometry. If it's trigonometry it's either Pythagoras or sin cos tan. Now remember, x and x are the same. So what type of right angle is it? It's a right angle isosceles, so we only need one side to use Pythagoras. So we did this question earlier on, c squared equals a squared plus b squared. So 12 squared is equal to x squared plus x squared. So 144 is equal to 2x squared. So 72 is equal to x squared. So x is equal to the square root of 72. And then the examiner says, so give your answer correct to 2 decimal places. So x is equal to 8.49. And again, are we dealing with centimeters? What do we do? It doesn't tell us. So 8.49 is absolutely perfect. So can you see from that 2018 question, if we have a strategy, which we now do, that's how we apply it. And it doesn't matter what type of question comes up in the exam, we apply that strategy. And that's always what we're going to do. Okay? And that's what we're going to do. We're going to give you a strategy that you can use to approach any question. That is what the weekly classes are all about. I mentioned when we started, we're here to give you the tools that you need in order to succeed in the exam, in order to maximize your potential, regardless of the type of students that you are. You know, everyone that comes in here is different, and we're here to cater for every type of student that comes in here. And that's what we do. And that's how you will succeed. It's by using the tips, using the strategies, the little helpful kind of tips along the way to approach any question. That's what we are going to do. That's what we will envisage for you. This is how you answer the question. This is how you approach this question. This is what you need to do for this particular type of question. So at the start of the class, within this particular back to school course, what I said is, look, we want to get something out of this. We want to make sure that when you leave, when you press stop on this video, you have a certain area of the course that's done. That's pretty much trigonometry done. They are the main elements, and if we use that strategy, you've got your 5 to 7% of the exam. Really important.
And really what it did is it gave us a little tip of what our weekly classes are like. In that actual handout that you've received, have a look when the classes take place. I'll be doing most of the classes, and again, we try to do it, as pain-free, as entertaining, as engaging as we possibly can. We appreciate that, when it gets to kind of, deep into winter and students, it's difficult to get here. We want to make sure that when you are coming, you're like, yeah, great, I can't wait, get another class done there. I'll get through my 29 weeks. I'm absolutely ready to blitz this exam. And that's the service that we're going to provide within the actual classes. So, you already have a great start for the year. Continue, keep working hard, whether you're going to do the classes with us or not, but get the head down as early as you possibly can. Unfortunately for you, you're definitely going to have a junior cycle exam to do. Last year's lads, they're the jammy, I won't say, right, but they're the jammy ones that didn't have to do it. You're definitely going to have to do it. So let's give yourself the best chance of succeeding in that exam. So, look, well done for tuning in. That'll be hugely beneficial before you actually get back into class, before you get back into school. Our classes are designed for you to achieve your potential, as I keep saying. If I see it in some of the classes, absolutely great. I'll have a chat to you. I'll tell you about what we're going to do within each class. As I said, we cover everything that's on the actual course, but ultimately we cover it based on the exam. How you can do well in the exam. We get rid of all the padding. We concentrate on the type of questions that come up. I'm here, as I said to you before, I'm here to show you how to answer the exam questions that come up in the exam. That is our goal. That is our objective each week that we have our weekly classes. So, well done for tuning in. I wish you the best of luck in your junior cycle. It's going to absolutely fly in. I'm sure I'll see a lot of you within the classes. Take care of yourself, and I'll chat to you soon.